Ever read something online and thought, could a robot have written this?
Yeah, it's getting trickier, right?
It really is. I mean, AI can now whip up text that sounds incredibly human. So the big question for you today is, have you ever actually wondered if you were reading something crafted by artificial intelligence?
That's exactly what we're digging into here.
Yeah.
How do we actually spot AI-generated text? It's becoming a really vital skill to develop.
Absolutely. And we've got some fascinating material to help us figure this out. We're looking at a study that's kind of like a forensic analysis of AI writing, pinpointing the telltale signs.
Right, digging into the characteristics.
Exactly. Plus, we're exploring research on autoencoders, which are, well, a pretty clever piece of AI technology that helps us understand how these language models work under the hood.
So think of these sources as giving us sort of a double-edged view on the challenge of what's called artificial text detection, or ATD.
Yeah, ATD.
Our goal in this deep dive is really to take these technical findings and make them clear and hopefully engaging for you. We promise we're not going to get lost in jargon.
No jargon, just the useful stuff. We want you to walk away with a practical understanding of the key things that can help you distinguish between human and AI-generated text.
Okay, so where do we start?
Well, let's set the scene. We're in a world pretty much dominated by these amazing large language models, the big names like GPT 3.5, GPT 4, Llama, Gemma.
Ones everyone's talking about.
Exactly. And they're not just spitting out random words. They can create really coherent, convincing text across all sorts of areas like finance, medicine, even really specific technical stuff like on Wiki CSI.
And while this tech is super impressive, it also opens up some tricky issues, doesn't it?
Definitely. If AI can create seemingly real text so easily, it can be misused. Spreading fake news, creating propaganda.
Or even facilitating more convincing fraud and scams. It's a serious concern.
That's where artificial text detection, ATD, comes in. It's a field that's growing super fast, dedicated to figuring out how to tell if text was written by an AI or a person.
Right. You might hear different terms for it: synthetic text, machine-generated text, neural text.
But they all mean pretty much the same thing. Text created by a computer, not a human.
What's really interesting, or maybe challenging, is how quickly this field has to adapt. New and more sophisticated AI language models are popping up all the time.
So the detection methods have to constantly evolve just to keep up. It's a bit of an ongoing race.
Yeah, a real cat and mouse game sometimes.
So let's dive into some specifics. One of our sources, a study often cited by its identifier, 2503.03601v1, really gets into the weeds of what makes AI text stand out.
How did they do that?
They use these things called sparse autoencoders, or SAEs. Think of them as a way to break down text into its most fundamental building blocks, its features.
And see which ones are being used differently by humans versus AI.
Precisely. By analyzing how these SAEs respond to different pieces of writing, the researchers could spot patterns in those fundamental building blocks, those features that were strongly linked to text created by AI language models.
Okay, so what did they find? What are these patterns?
Well, they found 5 really distinct features that seem to be the most reliable indicators across several models.
5 key things. What's the first one?
First up is feature 3608. Strong activations here correlated with what they called excessive complexity.
Excessive complexity. Like, just too many big words.
Kind of. The key insight is that AI sometimes overcomplicates simple ideas in a way that feels unnatural. Sentences packed with fancy words or complex clauses when a straightforward explanation would do.
Ah, okay. Like it's trying too hard to sound smart, maybe?
Yeah, maybe. It feels more like showing off than clear communication.
Got it. What's next?
The second feature, 4645, was associated with assertive claims.
Assertive claims. So just stating things very definitively.
Yeah, the takeaway is that AI tends to make these very definitive statements without the human tendency for, hedging or showing nuance. Humans often qualify what they say, maybe, perhaps, it seems like.
Right. We acknowledge uncertainties, consider different angles.
Exactly. AI, especially if you ask it for a direct answer, might sound overly confident, maybe too absolute.
Makes sense.
Okay, number 3.
Feature 6587, linked to wordy introductions.
Oh, we've all seen those. Long preambles that take forever to get to the point.
It's almost like the AI is trying to build up to its main idea in this very deliberate, sometimes really drawn-out way.
Instead of just getting straight to it like a person often might.
Yeah, exactly. Less direct sometimes.
Okay, feature number 4.
That one is feature 8264, which flagged repetition.
Ah, repetition. I can definitely see how an AI, maybe without a real grasp of conversational flow, might repeat words or phrases more than a person naturally would.
That's a key potential red flag.
Right.
While humans might repeat for emphasis or clarity, AI's repetition can sometimes feel more mechanical, less intentional, just sort of there.
Okay. And the last of the top 5.
Feature 14161. This one correlates with formality.
Formality. So it suggests AI might lean towards a consistently formal tone.
Yeah, even when maybe a human writer would adopt a more casual or context-appropriate style, it's about that level of formality in the language itself.
Even if you ask it to be informal.
Sometimes, yeah. Its sort of default setting, or its attempt at sounding authoritative, might still come across as a bit more formal than the situation really calls for.
What's really interesting is that these 5 features were apparently pretty good at picking out text from the more advanced GPT models like 3.5 and newer.
And others too.
Yeah, and other models like Llama and Gemma, especially when looking at writing in specific fields like finance, medicine, and that WikiCSI dataset.
But wasn't there an exception, something about scientific papers?
Yes, a really intriguing one. Texts from ArXiv, that place where scientists often share research pre-publication, those were harder to distinguish as AI generated.
So what does that suggest?
It suggests that these advanced AI models are becoming, well, very skilled at mimicking the specific style of academic and scientific writing.
Which is often quite structured and formal anyway.
Exactly. And it's not just about the overall style either. The researchers also noticed some peculiar little habits, quirks in how AI puts sentences together.
Like what? Grammar mistakes.
Sort of. They found more instances of things like having a space before a comma, or putting a comma right at the beginning of a new line, which is unusual.
Okay.
And using ellipses, those 3 dots, but sometimes with more than 3 dots. Little syntactic anomalies.
Interesting. So subtle glitches, almost like digital fingerprints.
Kind of. They pointed out that human writing isn't perfect either, of course, but these specific types of errors appeared noticeably more often in the AI text they analyzed.
So while you might not consciously register, say, a space before a comma while reading,
Right, you probably wouldn't notice just one.
these tiny inconsistencies, if they happen frequently,
Yeah.
could collectively add up. They might give you a subtle feeling that the writing isn't quite human.
Precisely. It's about noticing patterns and deviations from how humans typically structure sentences, even at that micro level.
Okay, so that study used sparse autoencoders. Let's maybe zoom out a bit and talk more about autoencoders themselves. They seem pretty central here.
Good idea. Our sources explain that autoencoders are a type of neural network, and they're fundamentally designed to learn a compressed version of whatever you feed into them.
Compressed version, like a summary.
Sort of, but maybe think of it more like, imagine taking a big image file and zipping it down to a much smaller size, but in a way that you can still perfectly unzip it back to the original. That's the core idea.
Okay, zipping and unzipping data. How does the network do that?
Well, an autoencoder usually has 2 main parts. An encoder, which does the zipping part. It takes the input, text, image, whatever, and squeezes it down into a smaller set of key features. This compressed version lives in what's called a latent space.
Latent space. The core essence, maybe.
Yeah, you could think of it like that. Then there's the decoder, which tries to do the unzipping. It takes those key features from the latent space and tries to reconstruct the original input as accurately as possible.
Ah, I see. So by trying to perfectly recreate the input after squashing it down, the network is forced to learn what the most important information, the most essential characteristics of the data actually are.
Exactly. It's a really smart way for the network to teach itself feature learning. We saw that older types, classical autoencoders, often use these things called fully connected layers.
Where basically everything is connected to everything in the next layer.
Right. And it's not just about making data smaller, this dimensionality reduction. Autoencoders pop up in some surprising places.
Like where?
Well, in communication systems, for example, they can be used to recognize different patterns in signals, like classifying different types of radio transmissions, just by learning their underlying structure from examples.
Interesting. Learning the shape of the signal.
Yeah. And we also learned about this idea of sparsity in autoencoders.
Sparsity.
Yeah.
Making things sparse, less dense.
Exactly. This is where you encourage the network to only use the most important connections or neurons. Think of it like telling a detective to focus only on the absolutely crucial clues and ignore all the background noise.
How do you encourage that?
through techniques like adding specific types of regularization during training, like L1 loss or something called KL divergence, which penalize the network for activating too many neurons.
So it forces the network to be efficient and find the truly essential features.
Precisely. And then you have denoising autoencoders. These are really clever.
Denoising, getting rid of noise.
Yes, you feed them corrupted input, say, a blurry or grainy image, and their job isn't just to reconstruct the blurry image, it's to output the original clean image.
Oh, wow. So they learn to actively filter out the noise and reconstruct the underlying signal.
Exactly. They learn what noise looks like versus what the real information looks like.
Okay, so how does understanding all this, the encoding, decoding, sparsity, denoising, how does this help us spot AI-written text?
Well, the idea is that by understanding how these autoencoders learn to represent text, what aspects they focus on, what patterns they pick up, what they might compress or even miss, we can get a deeper insight into the fundamental characteristics that might differentiate AI writing from human writing.
So by looking at those learned representations, those latent spaces.
Yeah, if you train autoencoders on lots of human text and lots of AI text, then compare those compressed representations, you might be able to uncover more subtle, more fundamental differences in the underlying structure or patterns of the writing that aren't obvious just from reading it.
A deeper level of analysis.
Exactly.
Of course, as we said earlier, telling AI text from human text is still, well, it's a tough problem. It's not solved.
No, definitely not. One of the big challenges the study pointed out is that detection gets much harder if you change the prompt style, how you tell the AI what to write.
Right. If you give it very specific instructions on style, tone, or topic, it can often get much better at blending in, sounding more human.
And the sheer speed at which new, more advanced AI language models are being developed means that detection methods are always playing catch-up. What works well on GPT 3.5 might not be as effective on GPT 4 or whatever comes next.
It's a constantly moving target.
It really is. It was also interesting that the study found the specific features that were best at general detection. Those 5 we discussed, like complexity and formality, weren't necessarily the same things that were sensitive to, say, the length of the text sample, or those little grammatical quirks like spaces before commas.
What does that imply?
It suggests we might need different tools or approaches, maybe a combination of methods to catch different types of AI-generated text or different indicators. Some methods for style, some for syntax, some for structure.
Yeah, that makes sense. There probably isn't one single silver bullet, one trick that will always reveal AI writing. It's likely more about a toolkit, looking at various aspects of the language.
This actually leads us nicely to a different angle from another one of our sources. This one looks at the idea of human subjectivity, our personal thoughts, feelings, perspectives, and how well AI can imitate that, particularly in journalistic writing.
Subjectivity, that feels like a really human thing.
Exactly. The article from Frontiers argues that while AI can definitely mimic the language humans use, truly capturing and expressing genuine human perspective is a much bigger challenge.
What's the core idea there?
Well, linguistically, the concept of subjectivity is inherent in human communication. It's always an I addressing a you, and that utterance is filled with markers of the speaker's identity, their emotions, their viewpoint, their stance.
Even in journalism, which aims for objectivity.
Even there. Journalistic writing, as this source points out, is still deeply influenced by human factors. The historical and social context it's written in, the specific institutions and standards of journalism, and just the unpredictable nature of events contingency all shape how stories are told by humans.
Right. Deeply human, contextual layers. Things in AI might not fully grasp or be able to replicate authentically, even if it uses the right words.
Precisely. The article talks about analyzing subjectivity on 2 levels. The text surface, things like word choice, lexicon, word forms, morphology, sentence structure, syntax.
The mechanics of the language.
Right, but also the situation level, things like appropriateness to the context, the strength of the argumentation, and how different voices or perspectives are woven together, which they call dialogism or polyphony.
Okay, so surface versus situation. What did they find about AI?
They found that AI can incorporate subjective markers on the text surface. It can use words that express opinion or emotion, for instance. It often struggles more with that deeper situational appropriateness. For example, really weaving together different voices or sources within an article in a natural, nuanced way that polyphony journalists use.
Or maybe how sources are cited and integrated.
Exactly. Using source citations with the kind of critical assessment or nuanced framing a human journalist would typically employ seems to be a limitation.
And how does this connect back to the features we discussed earlier?
Well, think about that feature for formality, feature 14161. It's possible that when an AI tries to sound like a journalist, it might achieve a certain surface-level formality.
Right, using formal words and sentence structures.
But it could be missing that deeper contextual understanding, that situational appropriateness that informs a human journalist's choices about tone and how they integrate different perspectives. It might be a bit hollow.
A surface imitation without the underlying substance or understanding.
That seems to be the idea. Finally, let's just briefly touch on the BOS benchmark. Our sources describe this as basically a standardized test track for AI detection tools.
Okay, a way to evaluate how well different detectors work.
Exactly. Evaluating them across different LLMs, different AI models, and different kinds of writing tasks like question answering, creative writing, summarization, etc.
And what were the main findings from BUSD?
A key finding was significant performance variance. How well these detection tools worked really depended on the specific task and the specific AI model that wrote the text.
So again, no single detector is best at everything.
Pretty much. A detector that was great at spotting, say, AI-generated answers to general questions might not be so good at detecting AI-written creative stories or text from a different model.
Did they identify any top performers?
They mentioned that one detector called LLMDE showed more consistent performance across different text styles. It was a strong all-rounder, you could say.
Okay.
But interestingly, another one, ChatGPT-QA, actually did better than LLMDA in certain specific tasks, like general question answering and creative writing.
So it specialized well in those areas.
Yeah, but then that same detector, ChatGPT-QA, struggled more when dealing with text generated specifically by GPT-4, especially in tests focusing on text length.
Right. This really just reinforces the point that detecting AI text isn't a one-size-fits-all problem. It's complex.
Absolutely. It depends heavily on the specific AI model used, the type of text generated, and likely the detection method itself.
Okay, so let's try and bring it all together then. What are the key takeaways for someone trying to navigate this?
Well, figuring out if a text is human or AI generated is definitely a complex, evolving challenge. But we've learned about several angles, looking for those subtle language patterns and features.
Like the excessive complexity, the assertiveness, wordy intros, repetition, formality.
Right, and also understanding a bit about how AI models work internally, using tools like autoencoders to grasp how they represent text.
And not forgetting the human element, considering those nuances of subjectivity and situational appropriateness that AI might struggle with.
Exactly. So you now have a better idea of some potential red flags to watch out for in the text itself, but also a glimpse into the deeper ways AI learns and produces language.
And while we're making real progress in developing detection methods, the rapid advancements in AI's own ability to generate convincing text mean this is absolutely an ongoing challenge.
Yeah, the ability to reliably tell the difference between authentic human writing and increasingly sophisticated AI mimicry, that's something we'll likely be grappling with for, well, probably a long time.
It certainly seems that way.
Which leaves us with a final thought for you, the listener. As AI writing becomes even more convincing, maybe even indistinguishable based on language alone sometimes, will just looking for these linguistic clues be enough?
Good question.
Will we need completely new ways to verify authenticity, maybe looking beyond the text itself? And perhaps most importantly, what role will our own critical thinking, our own judgment play in a world where it's getting harder and harder to tell the difference between human and AI-generated content?
That human filter becomes even more crucial.
It really does. This is a field with so much more to explore, and we definitely encourage you to dig deeper into some of the resources and ideas we've touched upon today.